This video is going to help you be able to simplify radical expressions. So up at the top of this worksheet that you're seeing are 4 things that could possibly help you. You may use one of these per problem, maybe you'll use 2 of these, you may use none of them, I'm not sure, but here are the things that I want to kind of talk about before I even start my first problem. Okay, so first thing, when you look at these problems, ask yourself, are any of the terms simplifiable? Okay, are any of these things simplifiable? For example, 25 to the 1/2, that actually equals 5. Okay, if something's simplifiable, simplify it first. Okay, second, exponents that are whole numbers are already simplified. You don't have to do anything to them, they are done. Okay, so don't feel like you have to be, trying to change those in any way. If they're a whole number, leave it alone. Also, if you can make it a whole number, leave it alone. For example, let's say you had x to the 6/3. Well, that's just x squared. All right, so again, simplify it. That's kind of going back to step 1. Simplify it and makes it a whole number, and then you're done. All right, step 3, and this is probably the most important one. When I start showing you these problems, you're going to see a bunch of exponents that are fractions. Okay, you're going to want to make sure to change those to be common denominators. Okay, common denominator. All right, because then you can put them all under a single radical, but that only works as long as they have a common denominator. All right, and then the very, very last little thing that I want you to look at is you'll know that something is simplified, right? All the way simplified when each base occurs only once, all right? And I have an example here. See how on this example right here, there's an x on the top and an x on the bottom? That's not simplified. That can keep going because you can reduce, right? You can cancel out one of those x's. Sort of the same thing is going to be happening on some of these examples. You may see more than one of the same letter, and you need to make sure to take care of that, or it's not all the way simplified. Okay, so let me adjust this and we'll get started. Okay, so I have 6 examples that I'm going to be doing with you. I want you to see these directions here. Let me highlight those for you. So notice that it says change each expression to 1 radical. Right? Just 1. So you may have to figure out what the denominator is to be able to get a radical. And notice it also says that you need to simplify. Okay, so just putting it under a radical is not enough. You may have to further simplify. All right, so let me zoom in. Let's do number 1. All right, so based on the directions that I gave you slightly earlier, which is anything here simplified, I can see that this m, it's fine, right? It has an exponent of 1. I don't need to do a single thing to the m. The m is good. I'm just going to rewrite the m. All right, now this n to the 1/4, right? I'm supposed to have a radical. I don't have a radical right now, so I'm going to write it as the 4th root of n to the 1st. You aren't even required to write that little 1 right there. If you just want to write it as m times the 4th root of n, totally fine. That is the answer. Scooting this over. Okay, so I'm looking at these 2, and neither one of these is simplifiable, right? There's nothing I can do to this x or to this y. But I do want it under a single radical. And right now, I can't do that because the denominators are different. So you have to kind of ask yourself, what do 3 and 5 both go into? And they both go into 15. All right, so if I'm going to change those fractions to be equivalent, that means this first fraction I need to multiply by 5, top and bottom, which gives me 10. Right, and the second fraction I need to multiply by 3, top and bottom, which gives me 3/15. And now, since these denominators right here are exactly the same, that's going to be the root, right? The denominators end up being the root. And then these 2 numerators up top end up being, again, they just remain the exponents, but now I have them under a single radical. All right, let's take a look at number 3. All right, now again, first thing is ask yourself, is anything here simplifiable? And this is, right? This is the equivalent of the cube root of 27, or in other words, 3. All right, because 27 is 3 times 3 times 3. Okay, now these other two, the 1/5 and the 2/3, I need to rewrite those so that I have a common denominator. In this case, it's going to be 15. So the first fraction gets multiplied by 3 top and bottom, and the second one gets multiplied by 5 top and bottom. And these two I can now put under a common radical because they have a common denominator. And I just have to make sure to bring the exponents along with them. All right, let's try number 4. All right, and again, feel free to, pause, replay, whatever you need to do. Okay, so I'm looking at number 4. This is crooked and it's bothering me. There we go. Okay, so I'm seeing 3 different numbers here. I see a to the 3rd, I see b to the 7/8, and I see b to the 1/2. Okay, of those 3, a to the 3rd has a whole number exponent. So it's done. I don't need to do anything at all to the a to the 3rd. So I'm just going to rewrite it. Okay, now these other 2 both have fractional exponents. So I'm going to get a common denominator for those. It's going to be 8, which means that the top one I don't need to do anything to, and the bottom one becomes 4/8. All right, so these two, right, they're the same exact letter. That means I need to actually simplify this. I don't know if you remember the rule, but if you are dividing the same bases, you subtract the exponents. So this actually equals b to the 7/8 minus 4/8, or b to the 3/8. All right, so now that I know what that is simplified, let me move this up a little bit. I already know that I have this that I didn't need to do anything to. And then this is going to be under a radical. All right, the radical is going to have a base of 8, and the b is going to have an exponent of 3. Okay, let's try number 5. Ooh, all right, so I see some stuff going on here. First thing, right, you're always trying to see if something is simplifiable. I have a feeling something's going on here, but I'm not quite sure. So let me rewrite this in radical form. So this would be the square root of 36 to the 3rd, which is, let's see, that's a 2. Let me change that, sorry about that. That's the square root of 36 times 36 times 36, which means there's a pair of numbers that gets to come out. That's 36 on the outside. Ooh, but check this out. Isn't there a square root of 36? There is. It's a 6 on the outside. All right, so 36 times 6, that's 216. Okay, so I have simplified the first number, but I still have to deal with, okay, this c, which actually is kind of okay. I don't need to deal with it at all because it has a whole number exponent. And then the very last term, I just need to write this under a radical. So the 4th root of d. That's a great problem. I like that one. Okay, and then we're on the very last one. I'm noticing first thing that I already have a common denominator. So let me go ahead and write this as the square root of 12 to the 1st times x to the 7th. Okay, now you've dealt with radicals before. This is simplifiable, all right? And I can tell because 12 is 2 times 2 times 3, and x to the 7th is 1, 2, 3, 4, 5, 6, 7 x's, all right? And I know that square roots mean to pull out pairs. So I'm pulling out a 2 and an x and another x and another x. So outside, right, all those things that are circled come out as single things. And then the things that aren't circled, namely that 3 and that x, those are going to remain underneath. So I get 2x cubed times the square root of 3x.